Welcome back to the lab. Tonight is a little bit different video. I've been getting a couple of emails about the Type 106 and the restoration I did on the Type 106. And I know there's some people that are struggling with some power supply issues with one of those. So I figured I'd make a video. One is the schematic in the service manual is a split schematic, which makes it really hard to understand. You got to flip back and forth between two pages. So I got that fixed. There's a full schematic right there. So I'll be posting that. And I took I scanned it with my high resolution image capture device, also known as my camera, because when I taped the schematic together, it was a little bit big for my scanner bed. That's why I had to chop off the bottom so I could get a scan of it as well. So what I'm going to try to do in this video, and if I miss any points, please leave a comment in the description down below. Let me know, because it'll only help people who are trying. It'll only help some people who are trying to restore one of these. I'm going to try to demystify this power supply. So what I'm going to do is I'm going to use the bank of meters that's slightly up there, and I'm going to take some measurements, and we're going to watch what the power supply is doing in real time. I'm also going to go through the block diagram and the schematic a little bit to try to help demystify it when everything's all said and done and the unit's cooled off again and there's no charge left. One of the things that's very helpful in troubleshooting some of this old tech gear is some of the manuals have a resistance reading of the supplies. So from the test point to chassis ground, you'll get a resistance reading, and that'll tell you if you have a short on your supply, if it's going to draw too heavy current or something like that. And that can be very helpful in troubleshooting some of these supplies, because they're, especially in the scopes, the supplies can be very interconnected and kind of strange. This one's kind of strange as well. So with that, let me get the block diagram in first, and then we'll get into it. Okay, so here's the block diagram of just the power supply for the Type 106. So as we can see, we have a supply, we have a 150 volt supply, a negative 20 volt supply, a negative 150 volt supply, and then two plus minus 10 volt supplies. So this block right here is our main power transformer, and then here are the rectifiers for the individual supplies, and then this is how they all interconnect. So on the plus minus 10 volt supplies, after this rectifier, those are ground referenced from here. This is the voltage references for the constant voltage sources, D213 and 216. These are the regulation circuits, Q213 and Q217, and then that just gives us our plus 10 minus 10 volt supply. So those aren't interconnected with anything. They're just they're referenced chassis ground, and they are separate. So pretty easy to troubleshoot there, and not really a sticking point. The sticking points that I've been running into are up in here, this big block right here, because everything is interconnected. And it comes to find out, none of this uses chassis ground. Everything is referenced to the A supply, which is actually a negative supply. So what's going on is, if we look at A supply and then we have a positive, A supply goes into a regulator, which is Q47, and then it's grounded. The positive side of A supply is ground referenced, which means A supply is a negative voltage supply. Now, what makes it even stranger is A supply is a variable supply. It can swing anywhere from negative 7 volts to negative 150 volts from ground. That is set by Q233 and 234 being a differential amplifier, feeding the regulator of 247 based on the amplitude switch on the or amplitude control on the front of the unit. So when you're dialing this control, you're actually varying A supply throughout the unit. Now, how does that tie in to everything else? A supply will be a set voltage from ground, whatever is set by the two adjustment pots and the differential amplifier and the regulator. The plus 150 volt supply will always be 150 volts more positive than A supply. So if A supply is at negative 150 volts, we have a regulated 150 volts. It's always 150 volts more positive than the A supply. The 150 volt supply should be 0, at least to ground, because the 150 volt supply is referenced to A supply, not ground. A negative supply, not ground. Same thing with the negative 20 volt supply. It's referenced, A supply is part of the constant voltage source for Q267 and the regulator Q227. So all we have going on here is we have a reference, which is usually a Zener in these, and then we have A supply, the D264 plus A supply comes into the constant voltage source of Q267, which then helps the negative 20 volt supply regulate. But the negative 20 volt supply through the amplitude is referencing A supply. So these two supplies are interconnected. And what you're doing is you're disturbing the balance. When you adjust the amplitude control, you're disturbing the balance at the differential amplifier, which is causing the supplies to move around. The negative 20 volt supply should always be negative 20 volts more negative than A supply. Same thing with the negative 150 volt supply. So the negative 150 volt supply should be, so if A supply is at negative 150 volts, the negative 150 volt supply should be essentially to ground negative 100, an additional 150 volts negative, so 300 volts with respect to ground. Because if we see the negative 150 volts is reference to A supply, positive 150 volts is reference to A supply, negative 20 volts is reference to A supply, plus and minus 10 volts are not reference to A supply. So with everything being interconnected like this, it can get really bizarre as to how everything is supposed to go. So what I'm going to do is I'll set up the meters, and I'm going to set them up two ways. The first way is I'm going to reference all of these to A supply, and we'll take some measurements. A supply should vary, but everything else should stay steady. We should have negative 20, negative plus 150, and minus 150. That should stay steady. I'm then going to do the same thing on the test points, but I'm going to reference everything to ground so we can see how everything is moving around. Here is the actual schematic, and I will post the supply schematic online at the bottom. All I did was chop off the heater circuit for the tubes. If the tubes are lighting up, this is good. Nothing we have to worry about, so there's no circuitry in there. So here's one of the references that I was talking about. So if we take the plus 150 volt supply, on the transformer winding we have 4 volts RMS, goes through a 10 ohm resistor into a bridge rectifier, into a bulk filter cap. D255, this is the Zener reference for the 150 volt supply, which then goes into a smoothing capacitor into the base of Q257. This has to be plus 150 volts due to the fact that that is 150 volt Zener. That's going to hold it up. So I do think that you should have a reading of about 151 volts there. We should be high, about 190 volts going into the collector of Q257. This is the pass element for the regulator. for the 150 volt supply. So the way this works, and here, right here is where it's referenced to A supply. So A supply comes in, and A supply is ground for the 150 volt supply. So what will happen is, as A supply moves, this will also float up and float down with A supply, but this will regulate 150 volts from A supply. So what we should have is at TP259, referencing A supply, we should have plus 150 volts, and that's regulated by this pass element. So this transistor, all this is doing, it's power transistor. Q257 is back there. So that's the pass element for the 150 volt regulator. He is coming up underneath there. So we have Q257, and all this is doing is, as A supply floats up and this fluctuates a little bit, this is just being a variable resistor, a very fast variable resistor, to drop 40 volts off of this 190 to give us a constant 150 coming out. A supply plus 150. Same thing down here, A supply minus 20. So if we come down here, here's our ground reference from A supply, comes in, junction point here, positive and resistor. We should have about a negative 7 volts here. And then this is our pass element, which is actually dropping quite a bit, because this is saying 132 volts. But we're dropping a lot of current through this 82 ohm resistor. Here's our reference, our 20 volt Zener in front of a current limiting resistor. So this is our reference for this transistor. So that's setting up the exact same way this is, just the polarities reversed. And we get 27 volts out here. Now we get 27 volts out here because A supply can only go, the lowest A supply can go is negative 7 volts. So the lowest this can go is 27 volts, negative 27 volts, because it's A supply minus an additional 20 volts. So we come down here, and it's the same thing. We actually have a heat-sinked transistor, which is this guy right here. Where was I? Oh yeah, heatsink transistor on Q227. Same thing, except the polarities reversed and all of our circuitry. Actually, we have A supply plus 150, so we have this feeding into this network here as well. So on the negative side of things, A supply minus 150, we could have, that could disrupt it if the 150 volts was off, because that will change all the bias points for the transistors. So, but at the if everything's functioning normally, collector of 224, we should have negative 25 volts. So they're using, collector 224 is actually an error amplifier for the reference and A supply. So the reference, D244, is the error is being amplified, and then that is going to the regulating the pass element, which is Q227. So this is just amplifying the error in the circuit, so 227 can correct. Because one of the reasons they had to do that was, back when this unit was made, power silicon did not have very much gain on it at all. The HFE of power silicon's pretty bad, so they'd put a amplifying element to drive the power silicon. That's actually one of the things that was wrong with my 7603. One of the drivers for the pass elements was toasted, and my 100 volt rail was at 140 volts because the power silicon wasn't doing anything. Pretty standard power supply, center tap, and then this one is actually, so this supply is chassis referenced because we have center tap on the transformer. We have center tap, and center tap. Pass elements Q213, Q to 17. These are just pass elements for the 10 volt supply. 10 volt supply is used for the fast edge connectors. It's not used for the high amplitude connectors. So if you're using the high amplitude and you're having a problem with that one, you're up in here, not down in here. With that being said, let me get some test gear hooked up, and what I'm going to do is add meters from left to right. I'll do plus 150, A supply, minus 20, and minus 150, and we'll see what everything does. Okay, here's my first test setup. I have the unit on now, so I'm going to be very careful about where I point my fingers. I'm nowhere near the unit. I'm about a foot away. You just guys can't see because of no depth perception in the camera. So A supply is right here, and my ground is right over here. So there's ground, A supply, and if I move up to the meter, mine's a little bit of an overachiever. It'll get down to 1.6. Nothing's going on, but all I'm going to do now is I'm going to turn up the amplitude control. So I'm going to turn up the amplitude control. Negative 174.6. So it's a completely A supply is a completely variable supply between. Oops, that's symmetry. Between 7 and 170 volts. It says 150. Mine's going up a little higher, probably because of line voltage issues. This was never designed for 120 volts. It was designed for 110. Okay, here's my test setup. I have the black wire hooked up to A supply because that's the reference for all the other supplies. That comes out to the green wire, which just comes to a junction point right here where I can hook all my probes up to. And then the red ones are plus 150, minus 20, minus 150. And if we move up to the meters, we should have plus 150, minus 20, minus 150. And everything's all stable, everything's warmed up, giving the tubes a chance to warm up. So we have 150, minus 20, minus 150. So all our rails are good. So what I'm going to do is I'm going to sweep the amplitude control front and back and let everything come up. So that's full on now. I have full square wave. And so I'll drop it back down. So I'm starting now. And it's all the way back down. I'm going to turn it back up. And it's all the way back up. So as you can see, when the power supplies are functioning normally with A supply as the reference, everything is good. I did notice something that I want to point out that might be an issue, might not be an issue. I didn't run into it, but this could potentially be a problem. I'm going to let the unit cool off for a little bit here real quick. I noticed these two neon bulbs. I don't know exactly what they're doing in circuit, but they may be buffering, giving the unit time to stabilize before and absorbing some current. So if I turn these on, the two neons light up. Both of them are lit, even the one underneath the capacitor, which you can't see. They both just went out. I still don't have oscillation yet. I just got oscillation. But those could be delaying the power supply, the high voltage rails, to let everything kind of regulate before they shut off and started doing their thing if anything went too high. So that could also be a potential problem too. I'll let the unit cool off again. All the charge is down. Because they had to do some things because this is a mix of silicon and tubes in the unit. So the rectifiers, they slam in. As soon as you hit the power button, you've got full voltage out of the rectifiers, but the tubes haven't actually come in yet. So there's some soft start stuff to let everything kind of warm up and stabilize and let the tubes come into emission. So I'll hit that one more time. And they're both out. So might be something else to take a look at and go from there. So what I'm going to do is I'm going to let this power down, unplug it, unhook all the meters, and I will do some resistance measurements from the different supplies. I'll do all the regulated supplies referencing a supply with the unit off, and then I'll do all the supplies to ground with the unit off, just to get the measurements to make sure you can sanity check the supplies before you fire it up. Okay, I've taken some measurement readings. The way this was done, amplitude is fully clockwise, and the first set of readings is test points to chassis. So on test point 259, 122K, that's the 150 volt supply. Negative 20 supply, which is test point 269, is 83. Test point 249 which is A supply, is 79.8. Test point 229, which is the negative 150 volt supply, is 94.1 k ohms. Moving down, amplitude control didn't change. These are the test points referenced to A supply test point. Test point 259 was 42.1. It was charging a cap and it settled at 42.1. That's the 150 volt. Test point 269 was 3.6K. Test point 249 was a short because it was A supply. And test point 229 was 8.4K. And that's the 150 volt supply. Given that A supply varies with the amplitude control and the ACAL control on the front of the unit, so just measuring across my ACAL potentiometer on the back side of that resistor to the other side of the pot, because of the way it's wired, the wiper is just connected to the resistor. My ACAL control was 2.82K, and my amplitude control was all the way clockwise. Thanks for stopping by the lab on this quick troubleshooting video. Hopefully this helps if you're having trouble getting a 106 up and running again. I'll find a way to post these documents online so they'll be available, especially the fixed non-split schematic. As always, if anybody has any questions, feel free to leave them in the comments. If I missed anything that may help with power supply troubleshooting, feel free to leave a comment and let me know. I'm waiting on some ICs to come in. As soon as those ICs come in, I will get started. I'm in the middle of shooting the next video for the channel, so as soon as those ICs come in, I'll be able to get another video out to you guys. So I'll see you in the next video.